Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that's fresh from the farm to your kitchen table. I'm James Messer, and in this module we're going to discuss wireless communication standards. This comes to us from our N10-004 Network Plus exam. Section 1.7 says that we need to compare the characteristics of wireless communication standards, and we have these 802.11 A, B, G, and N standards. We need to understand what are the differences in speeds, in distances, in channels, and in frequencies between all of those different types of wireless networks. There's also some technologies around authentication and encryption that we need to look at: WPA, WEP, Radius, and TKIP. So we're going to go through all of those in this module. Let's start with 802.11 wireless networking. What is this idea of wireless networking? You know, we didn't used to have wireless networks way back when. There was no wireless networks. Fortunately, the IEEE got together and said, let's make some. Let's come up with some standards for doing wireless networking. And what they came up with was a standard called 802.11. And the 802.11 committee came out with these different standards called A, B, G, and N. And these happened over time. They didn't all happen at once. We'll talk about how they came about. But these different networking technologies all exist today in some form or another. There's people all over using all four of those in different ways and in different places. So it's important that we know all four of those. There are differences here between all of these technologies, differences in speeds, differences in distance that they can travel, differences in what we call channels of communication and frequencies. And this is an important aspect of 802.11 networking. This is an example of the 2.4 gigahertz range that's used by the 802.11 B, G, and N in some cases. Now this 2.4 gigahertz range uses something called channels. The 802.11 said, let's make this easy. Let's say if you're on channel 11, then you're using a certain frequency. But you don't care what the frequency is. You just know you're on channel 11. Make sure all your equipment's on channel 11. Makes it very easy for us human beings to keep track of that type of thing. Each one of those channels corresponds to a frequency. And you can see 2.412. Channel 2 is on 2.417, channel 3 is on 2.422, and so on. Now, one thing you'll notice is that is the center of the frequency, but the frequency itself is 22 megahertz wide. That means that channel 1 overlaps a little bit with channel 2 and a little bit with channel 3. Channel 4 even overlaps a little bit there. Now you're noticing this overlap occur, which means that if you really wanted to be sure that multiple channels could work and multiple access points in your environment could work wirelessly and not conflict with each other, they need to be on channels that don't overlap. So in the United States, we use channels 1 through 11, and you'll notice the channel 1, channel 6, and channel 11 are some examples of channels that do not overlap or touch each other. So it's nice that you have these available, and what you'll find is most of the time when you look at an access point, it's going to be on channel 1, it's going to be on channel 6, or it's going to be on channel 11. Very rarely do you see any overlap between those. Now you are able to overlap, but if there is two access points or two channels close to each other, you may find that your throughput is going to drop because of interference occurring between those channels. This is a great chart. You're able to see that out on Wikipedia, which is where I got that from. So feel free to go out and look at 802.11 out there. Some really nice diagrams of how that's laid out. Let's talk about 802.11a. This was one of the original wireless standards. Came out in October of 1999, and it operated in the 5 gigahertz range. At the same time, there was 802.11b. It was in a completely different range. We're going to look at 802.11b in just a moment. And A was in this 5 gigahertz range, but it ran very quickly. It ran at 54 megabits per second. Especially compared to the other wireless technologies of the time, that was very, very fast. Now, this had a smaller range than 802.11b, relatively speaking anyway, because it ran at 5 gigahertz. If there were walls or other things in the way between you and that radio antenna that the access point had on it, the 5 gigahertz signal was absorbed very easily by other things that were out there. And so what we found is that if it was an environment that was cluttered with a lot of workspaces, then the 5 gigahertz 802.11a signal didn't go very far. The 802.11b seemed to work a little bit better, but it had its own challenges. We'll talk about that in a moment. The way most people will calculate 802.11a is they'll use a rule of thumb about a third of the range of 802.11b or 802.11g. That is because of that 5 gigahertz use. And it's one thing that we talk about the value of 802.11a because it's used in really very specific use cases today. It's nice having that speed wirelessly at 54 megahertz, but you usually see it in large open areas. Warehouses is great for 802.11a. It's very fast. There's not usually much in the way in a warehouse. You can put it up high. Nothing's going to get in your way. So it's very specific use there. You don't really see 802.11a rolled out in large or even corporate environments any longer. At the same time that 802.11a was rolled out, we got 802.11b. So it's another one of those original standards. Unlike 802.11a, the B standard operated in the 2.4 gigahertz range. This is a very common range, especially in the United States, to work. But unlike A, it only ran at 11 megabits per second. I say only, but at the time, having wireless communication of any kind was fantastic, and 11 megabits was certainly faster throughput, a data rate anyway, faster than 10 megabit Ethernet. So this was pretty good for a wireless communication, and many devices even today are still running 802.11b. Because it was running at 2.4 gigahertz, it didn't have to worry so much about absorption. So we got longer range than an 802.11a link. The problem, though, is there are a lot of devices running at 2.4 gigahertz. There's baby monitors, there's cordless phones, there's microwave ovens, Bluetooth devices use this 2.4 gigahertz range. And so today, even if you are on some networks that are just 802.11b, someone will start popping some popcorn in the microwave and suddenly you can't communicate 4 minutes at a time because it conflicts with those frequencies that you would normally see on the 802.11b networks. 802.11g came out as what you might think would be an upgrade to 802.11b. It came out in June of 2003. It again operates in the 2.4 gigahertz range, but is much faster. We're running now at 54 megabits with 802.11g, which means it's the same speed as 802.11a. Even some of the signaling that it uses is very similar, but there's a little bit less throughput because 802.11g needed to be backwards compatible with 802.11b. So it takes a little bit of a hit from a total throughput perspective, but the total data rate is 54 megabits per second. That's the number you need to remember for your Network Plus exam. It is backwards compatible with 802.11b, which means if you have an 802.11g access point, you have the option in most of those access points to allow both G and B communication to the access point simultaneously. It's a nice aspect of having that as an upgrade to the B. There are the same frequency conflict problems that we have here as the B network because it's using the same 2.4 gigahertz range. So that's something to keep in mind in those environments where you have the baby monitors and the Bluetooth and the microwave ovens. The latest version of wireless technologies is something called 802.11n. And there are devices today in both the consumer and the enterprise market that are available with the 802.11n draft standard, if you will. The standard isn't quite baked yet, and it's not yet ratified. Perhaps in the 2010 or close to 2010 timeframe, you're looking to see a ratified version of 802.11n. Now this operates in an option. You can choose to do 5 gigahertz, you can choose to do 2.4 gigahertz, or you could choose to do both. You've got a lot of flexibility with 802.11n, and it runs really fast. This is a total data throughput of 600 megabits per second is the data rate that it runs at, megabits per second. That is very fast compared to the 11 and the 54 megabits per second in the previous versions. This new standard has something called MIMO. This is our multiple input, multiple output. So you'll see some of these 802.11n wireless routers with multiple antennas on them because of that MIMO technology. There are devices, as I mentioned, already available. I can buy an 802.11n device from a store today, bring it home, unwrap it, plug it into my network, and use it. But what you tend to have to do is make sure you use the same manufacturer's access point as you have for the cards that are in your machine. That's not always the case. but the standard is not quite baked yet, so there may be some incompatibilities. An important thing to think about is that the device that you're buying, make sure that it says that it will be upgradable to the final ratified version when it is standard. Not all early 802.11n devices were upgradable because they didn't know what that standard was going to do, so they couldn't build in all the hardware that they might need. These days, almost all devices are going to be upgradable, but something you should check for on your wireless router. Here's a summary of some of the information we were just talking about, the 802.11a, b, g, and n. The frequencies that they use, those are important things for you to know for your Network Plus exam, as is the maximum theoretical throughput, the data rates for those networks, the 54, 11, 54, and 600 megabits per second. Now, I also added on here an approximate range for these. The challenge with determining the real range of these networks is that you never know the environment you're going to be in. You don't know what interference is going to be there. You don't know what devices are going to be between you and the antenna that's on the access point. There's a lot of variables in play. But I took these values right out of Wikipedia to give you at least a relative term of what you might expect to see on an exam. Your Network Plus exam may go higher or lower around this, but if you remember which has the smallest range, which has the longest range, and you can keep track of those types of things, you should do pretty well for your exam. One of the greatest things about wireless networks is you can connect to them from anywhere. You're not tethered. One of the worst things about wireless networks is you can connect to them from anywhere. You're not tethered, which means that if you're trying to get on a network and do some bad things, and a network allows you on there, you now have access. So adding the ability to authenticate and encrypt data over these wireless networks was pretty important. So let's look at these wireless security technologies. Now, from an authentication perspective, these are technologies that allow people to get onto the network. Who has access onto this network? We're going to look at an authentication technology called Radius. It stands for Remote Authentication Dial-In User Service. And that is one that many organizations use to manage the authentication to the wireless networks and other networks as well. We'll also talk about encryption, which is an extremely important part of wireless networking. You do not want to be on a wireless network and be in an environment that is not encrypted. You don't want to have it so that people can see the data you're sending over the network. You want to make that data unreadable, and we do that through these encryption technologies. We're going to talk about WEP, and we're going to talk about WPA, which also is a term that we use for TCAP. We're going to talk about the similarities between those two and how those are interchangeable. As I mentioned, Radius stands for Remote Authentication Dial-In User Service, and it is a protocol that's used for something called AAA. In the security world, that's authorization, authentication, and accounting. This Radius is used not just for wireless networks, although you can certainly use it for wireless. People will use it for VPN connectivity. They'll use it for access to routers on the network. It's a great authentication device. It's a set of protocols used just for authentication. And there are a number of servers that will use that protocol to allow you access onto the network. It's a way that you could also centralize the management. You go to one server, James is allowed on the wireless network, you put it in one place, and when I log in, my login process automatically knows to go to my Radius server and check to see if I really have access to that wireless network. There's many different kinds of Radius servers and Radius services that are out there. Some are free, some are commercial, some come with your servers, some don't, but it's a very common protocol, and it's used in almost every small, medium, and large organization in the world. Well, now that we've authenticated ourselves to the network, let's encrypt the data that we're sending across the network. One encryption technology is something called WEP, or Wired Equivalent Privacy. It was one of the original encryption types used on wireless networks, and it had different levels of key strengths for this encryption, one that was a 40-bit key and one that was a 104-bit key. Now, the problem with WEP is there were some very serious cryptographic vulnerabilities identified in WEP in the 2001 timeframe. You could get into any WEP communication in just a few minutes by performing some very easy functions. There were some programs that came out that really cracked it wide open. And suddenly, our industry got a little bit crazy because you could be on a wireless network and people had the ability to decrypt your traffic. That certainly is not what we were expecting when we were encrypting our data. Today and going forward, evermore, do not use WEP. Just don't use it. It's still an option in your routers. It's still there for backwards compatibility. But you don't want to use WEP encryption because it essentially is the same as being wide open from a hacker's perspective. It's very easy for somebody to get into these wireless WEP encrypted packets and decrypt them. Not very difficult at all. So don't use it. It's not very secure. What you should be using is something called WPA. This is something that comes from a technology called TKIP, Temporal Key Integrity Protocol. So WPA was built right on top of this. And when we were having all these problems with WEP, we were trying to figure out where do we go from here. Let's use TKIP. And we'll create this bundling of encryption technologies, and we'll call it WPA. So it's essentially the same thing as we use it in wireless terms. What's nice about this is every packet gets a unique encryption key. It's a very secure way of communicating. This is something now we call WPA, or Wi-Fi Protected Access. There was an early version called WPA and then some other capabilities built around it with TKIP that finally ratified we call WPA2. There's another version called WPA2 Enterprise. You'll see that inside of your wireless routers. This certification really started in the 2004 timeframe. So this has been around for a while. We feel very comfortable that from a cryptographic perspective that we have not had the problems we had with the WEP encryption. Hopefully going forward we've got a very solid encryption protocol and we can continue to use this going forward for a very long time. Now this uses something called a pre-shared key as well. It is 8 to 63 ASCII characters that I would type in, and I can make these really nice passphrases that have to match up to what's on my router and what's on my workstation. So we've got a lot of security capabilities here and the ability to set some very complex passphrases so that nobody can maybe brute force and try to figure out our password, because we can make it very complex. Let's see how well we remember some of these wireless technologies and communication standards. Which frequencies are used in the 802.11g networks? Do you remember? Well, if you recall, it was an upgrade to 802.11b, and 802.11b was using our 2.4 gigahertz, so therefore 802.11g is using 2.4 gigahertz as well. Which wireless technology provides the fastest data rate? There were four that we were concerned with: 802.11a, b, G, and N. Which one was fastest? Do you remember? Well, it was the latest. It's 802.11n at 600 megabits per second. And finally, what is the most secure method and the only one you should be using for encrypting your wireless communication? Well, that's WPA, or WPA2 in its final form, something called Wi-Fi Protected Access. Well, that covers our wireless communication standards from our N10-004 Network Plus exam, section 1.7. We've gone through all four of those wireless technologies, the 802.11a, b, g, and n, and we've looked at how we can authenticate with Radius and how we can encrypt and protect our data with WEP and with WPA. For more Network Plus exams, to participate in our message boards or drop me a line, you can visit our website, freenetworkplus.com.